Alright, this video is going to be on three-term ratios, and I'm going to extend that. I mean, we could have more than three-term ratios. We could have 4 or 5-term ratios. We can have as many terms in there as we want, so long as we have different things we can compare. But if I was to look at doing, let's say, a three-term ratio, so I've got a couple of them written up here. So we'll go back to the marbles. I've got blue, red, and green marbles. And if I wanted to compare the number of red to blue to green, I'm simply going to count up the number of marbles and make sure I put them in order, right? So the number of red marbles, there are 4 of them. The number of blue marbles, there are 2 of them. And the number of green marbles, there are 6. So my ratio is going to be 4 to 2 to 6. And really I just keep the order in whatever it is in the question, put the numbers in. Now, that ratio 4 to 2 to 6, I can put that ratio into lowest terms. They all have a common factor. This is the easy common factor to spot. They all have a common factor of 2. So every term in that ratio can be divided by 2. So if I was to put it in lowest terms, 4 divided by 2 gives me 2, 2 divided by 2 gives me 1, and 6 divided by 2 gives me 3. And to get there, I really just took each term and I divided each by 2. Okay? Oh, sorry, those ended up looking like plus signs because I didn't pull my pen back far enough. Okay? So as long as you are multiplying or dividing all terms by the exact same value, you find an equivalent ratio. And if we're dividing, we want to keep pulling out common factors until it goes into lowest terms. Now, if I was to change that ratio around and write green to red to blue, so I'm still going to have the same numbers. There were 6 greens, there were 4 reds, and there were 2 blues. And as we put that ratio into lowest terms, I'll just write LT. Again, that would be 3 to 2 to 1. Okay? If I have a ratio, unless I'm specifically told not to, we always want to put that ratio into lowest terms at the end. Okay. Now there's another way I could look at this. We've been just comparing all of the different parts, but I could look at the different parts and I could compare them still towards the total. So I could say like blue to green to the total number of marbles. Well, there's 2 blue ones, there are 6 green ones, so it's 2 to 6, and then the total number of marbles, so the 2 blue and the 6 green is 8, plus the 4 red would give me 12. So I could also include the total as one of the terms in my ratio. And again, if I put that into lowest terms, that could be written as 1 to 3 to 6. Now I probably wouldn't want to do that if I'm looking at the total, because it's nice to know that in total I have 12, but absolutely this can still be put into lowest terms. Okay. Now, I did say, yes, 3-term ratios. However, I could look at all of my parts together. So I could say blue to red to green. Oh, I should write the word to green to the total. So I could compare everything all together in one. So there were 2 blue, there were 4 red, there were 6 green, and there were 12 total marbles. So I could compare all of my parts and my total in one ratio and have 4 terms, and that's totally acceptable. You can have as many terms in your ratio as you like, so long as you have different parts to compare. Okay. All right, if I was to put that one into lowest terms, it would be 1 to 2 to 3 to 6. And notice that these parts here, right, these all, when I write my different parts, add up to the total, right? These 3 parts here all added up to my total. Okay, now that's not the only equivalent ratio I could have found, right? I could have said, what if I had 2 blue and 4 red and 6 green for 12 total marbles? How many green marbles am I going to have if I have the same ratio but 72 marbles in my bag? If there are 72 marbles in the marble bag, how did I get from 12 to 72? Well, that one I would have to multiply by 6. Well, to keep an equivalent ratio, I need to multiply every single value in my ratio by 6. And that gives me 2 times 6 is 12, 4 times 6 is 24, and 6 times 6 is 32. Okay, I still have the same ratio, still the same comparison, still the same proportion between all of my marbles, and now there would be 12 red and 12 blue, 24 red, and 36 green. If you do look at them, 24 plus 36 gives me 60, plus 12 is 72, so it still adds up to the total number of marbles that we're supposed to have in the bag. Okay, so I can still find equivalent ratios regardless of how many terms there are, just like I would with a 2-term ratio. Okay, so really 3-term ratios or more behave exactly the same way, and that should make it pretty simple to just keep adding extra terms on.